Yo, what is up, guys? It's Freddy Knows Ball, and we're back here with a brand new video today. Let's get right into it. Alright, guys, so if you remember my lesson on expressions, correlated coefficients is slightly similar. We'll be just going straight into the practice, and I'll explain these strategies once we get there. And we're here. So let's go ahead and read this. The expression 2x squared plus ax is equivalent to x times 2x plus 7 for some constant a. What is the value of a? Alright, so to solve this, you essentially have to look at how you can make the expression look the same as x times 2x plus 7. So we can plug in answer choices here, and my go-to would be 7 because I see a 7 in the expression that's equivalent to it. So if I try plugging in 7, then the x factors out and it becomes x 2x plus 7. And so I know 7 is the correct answer. That's how I would go about solving that one. If you guys have different ways to solve these or you think there's easier methods, feel free to go leave them in the comments below, guys. It is absolutely a space where even I could improve, and it would be great to have some feedback. We have a slightly more difficult question here. Let's go ahead and give it a go. If the given expression is rewritten in the form 2x minus 3x plus k, where k is a constant, what is the value of k? Alright, so I'm seeing that that's a factored form. So I'm really just going to try to factor this equation. There's no real reason to use Desmos, so I'm going to factor by grouping here, guys. If you haven't learned factored by grouping in algebra yet, it's essentially where you multiply a and c. So 2 is a, 5 is b, and negative 12 is c here. So I'm going to multiply a and c to get negative 24. Now I have to find two numbers that multiply to negative 24 and add to positive 5. So let me think. We see 3 in our expression, and so I'm going to try to get 3 in there, and 3 and 8 works. Positive 8 and negative 3. 8 minus 3 is 5, and 8 times negative 3 is negative 24. So that works perfectly. So now I'm going to write out 2x squared plus 8x minus 3x minus 12. And so when you group those together, you have 2x squared plus 8x in a group and negative 3x minus 12 in a group. It can also work the other way around if you want to switch the 8x and the negative 3x, that's fine. But I'm going to do it this way. So I can factor out 2x, and we're left with x plus 4. And then I can factor out negative 3, and we're left with x plus 4. So now if we combine the x plus 4, so now we go 2x minus 3, x plus 4. That's our complete factored by grouping expression. And when we look at the question again, we see that k equals 4 because the way we factored it, it came out to be exactly how the expression is written. So 4 is our correct answer. All right, here's another question type you're likely going to come across on the SAT. This is a scatter plot, and I just want to show you guys how to be able to conceptually understand the linear model here. So which of the following equations is the most appropriate linear model for the data shown? So we can see that the scatter plot is going downwards. It has a downward trend. So the slope is negative, and the y-intercept is around 10, and it's looking like that the x-intercept is actually also around 10. So I'm just trying to look for something in the answer choices that has a negative slope and a y-intercept around 10. What's interesting about this one is it's not in y equals mx plus b form directly, right? It has the b value in front of the m, which is sort of something that they probably use just to throw you off. But if you can identify that negative slope is the m value, which comes right before the x, so we know it's not going to be so drastic that it's 9.4. So we know that 0.9 is our slope, and we know it's negative. And just based off of that, we know that the answer is D. We can also see that the y-intercept is 9.4, which with a line of best fit would make sense. And yeah, once you identify that the slope is negative and it's roughly 1, you can just come to D as the conclusion. That is going to wrap up the video for today, guys. I hope you enjoyed. Please feel free to like and subscribe, as well as leave any questions you have in the comments below. And I'll see you guys in the next one. Peace.